The next example considers the case where we need to determine if we have enough characterized resources of one kind to match the next characterized resource of another kind. For example, in the figure shown, the question is this: do we have enough SteelShapes to load the next flatbed that will be loaded by activity load shapes? In this case, flatbeds line up and must be served in strict FIFO order. Moreover, a flatbed cannot be loaded with less than 75% of its payload, and SteelShapes must fit in flatbed, that is, their length must be less than or equal to the length that can be accommodated in the flatbed. The first statement defines the characterized type flatbed and shows its two properties, payload in tons and length in meters. After that, we have the definition of a safe prop for a flatbed called entry num. This safe prop will be used to access the flatbed that is in the front of the queue. After that, we have the characterized type SteelShape that has two properties, weight in tons and length in meters. After that, we have the generic type crane. The next statement assigns to the safe prop entry num the total count of the resources that have entered queue flatbed's weight every time a resource enters flatbed's weight. Then we have the statement that defines the filter next flatbed, which applies to resources of type flatbed and whose logical expression compares the entry num of the flatbed cursored to the minimum value of the entry nums of the resources in queue flatbed's weight. The purpose of this filter is to identify the flatbed which is at the front of the queue flatbed's weight. The variable next flatbed length returns the length of the next flatbed in flatbed's weight. The variable next flatbed payload returns the payload of the next flatbed in flatbed's weight. Notice that both variables apply the filter next flatbed to the queue flatbed's weight, and as a result produce a subset that contains only one flatbed, the flatbed in the front of the queue. The first variable returns the length of that flatbed, and the second variable returns the payload of that flatbed. Then we have the definition of the filter called fit in next flatbed, which applies to resources of type SteelShape and whose purpose is to identify those SteelShapes that actually fit in the next flatbed to be loaded. This is accomplished by the logical expression which compares the length of the SteelShape currently cursored by the filter to the variable next flatbed length. This means that a SteelShape fits in the next flatbed if the length of the SteelShape is less than or equal to the length of the next flatbed. This is followed by the definition of another variable that saves even more typing. This variable is called total weight of shapes that fit, and it returns the sum of the weights of those SteelShapes that fit in the next flatbed. In other words, we apply the filter fit in next flatbed to the SteelShapes that are in the queue SteelShapes weight, which creates a subset of those SteelShapes that fit in the next flatbed, and then we sum their weights. All these statements do not do anything until they're used, and their use is in the enough statement for link SS1. The logical expression for this enough statement has a left-hand side that is the total weight of shapes that fit, which is compared to and has to be greater than or equal to 75% of the next flatbed payload. This logical expression is almost self-explanatory because of the naming of the variables involved. On the left-hand side, we have the total weight of shapes that fit into the flatbed. And on the right-hand side, we have 75% of the payload of the next flatbed. This means that we have enough SteelShapes if the total weight of shapes that fit is greater than or equal to 75% of the payload in the next flatbed. If the enough attribute for link SS1 returns the value true, along with the other links that entered the combi load shapes, then load shapes will create an instance. It will then be necessary to draw resources through link SS1 that match the flatbed that is already drawn into load shapes. For this to work, it is necessary that link FB1 be defined first before the link SS1. The expression for the DrawWhere attribute of link SS1 is a logical expression that is an AND statement with a left side and a right side. On the left side, we have a comparison of the length of the SteelShape that is currently cursored by link SS1 to the length of the flatbed in load shape. In other words, for a SteelShape to fit in the flatbed, its length must be less than or equal to the length of the flatbed that has already been drawn and is inside the combi load shapes. However, that is not enough. There is another condition that must be satisfied. The other condition is that the weight of this SteelShape must be less than or equal to the remaining capacity of the flatbed. The remaining capacity of the flatbed is the payload of the flatbed in load shapes minus the sum of the weight of the SteelShapes that have already been drawn and are inside the current instance of load shapes. As a result, this DrawWhere statement makes sure of two things. The first thing is that the SteelShape to be drawn must have a length that fits inside the flatbed, and the second thing is that the weight of the SteelShape will not make the total weight of SteelShapes in the flatbed exceed the flatbed's payload. The last statement is the draw until for link SS1. The logical expression for this draw until compares the sum of the weight of the SteelShapes in load shapes to be greater than or equal to the payload of the flatbed in load shapes. In other words, this draw until allows link SS1 to draw until the sum of the weights of the SteelShapes that have been drawn are greater than or equal to the payload of the flatbed in load shape. Notice that the sum of the weights of the SteelShapes in load shapes can never be greater than the payload of the flatbed because the DrawWhere statement does not allow this to happen. As a result, the only way for the draw until to be satisfied is for it to be satisfied as an equality where the sum of the weights of the SteelShapes in load shapes equals exactly the payload of the flatbed in load shapes. This might never happen, but SS1 will continue to draw until it goes through all the SteelShapes available to see if that can be achieved. The behavior of the filter next flatbed when applied to the Q flatbed's weight is illustrated in this figure. In the center, we have a table that represents the Q flatbed's weight, showing 4 resources, each of which has 4 properties: resnum, entry-num, payload, and length. On the left-hand side, we have an arrow that represents the cursor of the filter next flatbed. On the right-hand side, we have the logical expression for the filter next flatbed. The logical expression is entry-num equal flatbed's weight dot entry-num dot min-val. When we apply the filter next flatbed to the Q flatbed's weight, the filter will cursor the first resource in the queue, which has resnum 1, and it will ask the question, is your entry num equal to the minimum of the entry num properties of all resources in the queue? The question asked really is 13 equal to 13? The answer is yes, so the first resource passes the filter and enters the subset formed by the filter. The same question then is repeated for the second, third, and fourth resources in the queue. Because their entry nums are 14, 15, and 16, which are not equal to 13, those resources do not enter the subset formed by the filter, and thus the subset contains only one resource, the one whose res num equals 1, whose entry num equals 13, whose payload is 8, and whose length is 22. Thus, the variable next_FlatBed length, which applies the filter next_FlatBed to the queue_FlatBed's weight and returns the property length, returns the value 22. The variable next_FlatBed payload, which returns the property payload of the resource in the subset formed by the filter next_FlatBed when it's applied to the queue_FlatBed's weight, has the value 8. When the enough statement for link SS1 applies the filter fit in next_FlatBed to the queue SteelShapes weight, the filter cursors the first resource in the queue, which has a res num 1, weight of 1.5, and length equal to 18. It then evaluates the logical expression to see if the length of the currently cursored SteelShape, which is 18, is less than or equal to the next_FlatBed length, which is 22. This inequality is true for the first resource that has res num 1, so this resource passes the filter. The filter then cursors the second resource in queue and asks the same question. Is your length, which is 22, less than or equal to the length of the next_FlatBed, which is also 22? So the second resource also passes the filter's test and becomes part of the subset. The filter then cursors the third resource in queue and repeats the same question. Is your length, which is 24, less than or equal to 22? The result is false, and as a result, the third SteelShape does not pass the filter and is not made part of the subset. The filter then cursors the fourth SteelShape and repeats the question and compares the length 22 to 22. So the fourth SteelShape also passes the filter and becomes a member of the subset. So the resulting subset of applying the filter fit in next_FlatBed to the queue SteelShape's weight produces a subset that has 3 elements in it that have res nums 1, 2, and 4. All characterized resources that pass the filter form a subset called SteelShapes weight.fit in next_FlatBed. To use this set, we need a property and a set operator. This is done, for example, by the variable total weight of shapes that fit, which returns the sum of the weights of all the resources in the subset. In this case, it adds the numbers 1.5, 2, and 4 and returns the result 7.5. We should also remember that the next_FlatBed payload has the value 8. This means that when we evaluate the logical expression of the enough statement for link SS1, on the left-hand side we have the value 7.5, and on the right-hand side we have 75% of 8. 75% of 8 is 6. 7.5 is greater than or equal to 6, so the result of the enough attribute for link SS1 is true. This means that for this example, combi load shapes will be able to create an instance. The new instance of combi load shapes will then draw the first flatbed in the queue flatbed's weight. That is the flatbed with rest num1 whose payload is 8 and whose length is 22. After that, the new instance of load shapes will draw SteelShapes through link SS1 by using the logical expression in the DrawWhere statement. Link SS1 will cursor the first resource in the queue with rest num equal to 1, check that its length is less than 22, and that its weight is less than the available capacity of the flatbed, which at this point is 8. As a result, the first SteelShape in the queue will be drawn. The draw until is not satisfied, so link SS1 will cursor the second resource in the SteelShapes queue and check to see if its length is less than or equal to 22, which it is, and then also check to see if its weight is less than the remaining capacity on the flatbed, which is 8 minus 1.5, which gives us 6.5. This means that the second resource with rest num equal 2 will also be drawn into the starting instance of the activity load shapes. Again, the draw until for link SS1 is not satisfied, so link SS1 will move its cursor to the third resource in queue and check to see if its length is less than or equal to 22. Because it is not, this resource will not be drawn, and instead link SS1 will cursor the last resource in queue, which has a rest num of 4. The DrawWhere logical expression will then check to see if the length of the currently cursored SteelShape, which is 22, is less than or equal to the length of the flatbed, which is 22. That is satisfied. It will then check to see if the weight of the currently cursored SteelShape, which is 4, is less than or equal to the remaining capacity of the flatbed. The remaining capacity of the flatbed is 4.5. As a result, this condition is also satisfied, and thus the SteelShape with rest num equal to 4 will also be drawn and loaded into the flatbed. At this point, drawing through link SS1 is complete, and drawing will possibly continue with another incoming link to the starting instance load shapes.